welcome to Inspire Tutorial. This is Yasin and today's topic is chemical effects of electric current. In this topic, we discuss how to test the conductivity of a substance or a material. How can we detect the flow of low current using LED bulb, and what is LED bulb? Why can't we handle electrical appliance using wet hands? What is electroplating? How can we coat expensive metals like gold and silver on the metals like iron? First, let us see how to test the flow of current through a given substance. For example, you have an iron nail and I want to know whether current can pass through the iron nail or not. To test the conductivity of a given material or a substance, we'll have the arrangement like this. So for this, we require a battery and wires and a bulb, and the arrangement will be done like this. And if I want to know whether an iron nail can conduct electricity or not, so I will take the iron nail here and I will put an iron nail between these two ends. If the bulb glows, it indicates that iron nail can conduct electric current. When you take a piece of aluminum wire and if you put it aluminum wire over here, and you can see the bulb glows, so that means aluminum wire also a conductor of electric current. Similarly, if you replace this aluminum wire with a piece of plastic, now the bulb doesn't glow. What does it mean? The plastic is not a conductor of electric current and we can call it as insulator. Similarly, we can test the flow of current through liquids. So we can test the flow of current through the liquids like tap water or lemon juice or acid, etc. To test the flow of electric current through a liquid, you are going to take a small bowl. For example, if you want to test whether current flows through lemon juice or not, so we'll take a small bowl like this and it is filled with small amount of lemon juice, and now these both the ends will be kept inside the juice or this liquid. Then if the bulb glows, it indicates this is a conductor of electric current. But sometimes what happens, the liquid is a poor conductor of electric current. You may not see the bulb glowing because that weak current is not sufficient to glow that bulb. So in that case, we use LED bulb, means light emitting diode. So we replace this bulb with an LED bulb. In this LED bulb, we'll have two LEDs. So in these two LEDs, one will be longer, the other will be shorter, and we connect the longer LED always to the positive terminal and the shorter one to the negative terminal of the battery. Now when you keep these two ends in this liquid, the LED bulb can glow even for the low currents. If this is a poor conductor of electric current, it can conduct very small amounts of electric current. So for that current also, the LED bulb can glow, and depends on the intensity of the light of this LED bulb, we can say whether this liquid is a good conductor or a poor conductor of electric current. We can use a magnetic compass also to detect the flow of electric current through a circuit. And when you take distilled water, it does not conduct electric current, but when you take tap water, it can conduct electric current. Not only tap water, if you take water from the well or water from the ponds or rivers, the water can conduct electric current. The reason for this is, if you take distilled water does not contain any minerals, whereas in tap water or the water from the ponds or wells, it contains some minerals dissolved in it. So due to the presence of those minerals, in the water, it allows the current to pass. So that is the reason why we should not handle electrical appliance with our wet hands. Let's see what happens when you pass electric current through water. As distilled water does not conduct electric current, we cannot use distilled water. So I'm going to use tap water over here. So I'm going to take a container. So in this, I fill this with tap water. So in this, I'm going to use 2 carbon electrodes, or instead of these carbon electrodes, you can use iron nails also, each of around 6 centimeters or 10 centimeters. And these 2 electrodes are connected in the circuit like this. When the switch is on, so now the switch is on, then you will observe some gas is released at both the electrodes. Some gas is released at both the electrodes, means you can see some bubbles over there. So here the electrode, the one which is connected to the positive terminal, so here the gas released is hydrogen, and the electrode which is connected to the negative terminal, so this is positive and this is negative terminal, so here you will get oxygen gas. So this is what happens when you pass electric current through tap water. Otherwise you can take water in which some salt is dissolved. If you replace the tap water with copper sulfate solution, let us see what happens. When you take copper sulfate solution in this container, and if you pass electric current using the electrodes, then what happens? Here you can observe the blue color of the solution fades. If you continue the process for another 15 minutes, and then if you take out those electrodes and observe, what will you see? You will see pinkish brown deposit on the electrode which is connected to the negative terminal. So in this, what happens? The copper sulfate which is used, that will dissociate into copper ions and sulfate ions, and these copper ions from the solution, they will go to the negative electrode, and there the copper will be deposited. Since the copper ions are going to the negative electrode and the copper is deposited on the negative electrode, what happens? The blue color of the solution fades, because the blue color of the solution is due to the presence of these copper ions. As the copper ions are depositing on the electrode, so there are no more ions present in the solution, hence the solution will lose its color. So these are the few chemical effects of electric current. In some reactions, what happens? Gases can release, or in some reactions there will be some deposit on the cathode, or the color of the solution may also fade, or the color of the solution may also change. So here from this we can understand one thing. So the metal which is present in the solution, that will go to the cathode, that is negative electrode, and the metal will deposit on that negative electrode. So this principle can be used in electroplating. Electroplating is the process in which one metal will be coated on another metal. For example, when we take keys or any other article which is made of iron, so there is a chance of getting rust, because iron can easily get rust. So that is the reason why we coat iron articles with other metals. So in this we'll see how can we coat an iron key with copper. So here also we are going to take the same arrangement. So where we are going to take copper sulfate solution, and this time you have to coat iron key with the copper. So we are going to take the key made up of iron as the negative electrode, or it is connected to the negative electrode, and we are going to take copper plate which is connected to the positive terminal. So when you switch on this circuit, what happens? The copper ions which are present in the solution, they will go to the key, and that copper will deposit on the key, At the same time, since copper ions are losing from the solution, the positive electrode is made of copper. So this copper will release copper ions into the solution. And again those copper ions will go to the key and they will deposit on that key. So this process goes on till you will get a thin layer of copper over that key. So the purpose of electroplating iron articles or any other article with other metals is to prevent those articles from rusting and to give some attractive appearance. Using this electroplating, we can coat the metals like chromium on the articles or things like bath taps, wheel rims or bicycle handles, etc. And we can even coat the expensive metals like gold and silver on other metals like iron. These are the few chemical effects of electric current. So this is the topic, the effects of electric current.